Hi friends, welcome back to my channel Universe of Physics. In the last video we discussed about threshold wavelength as well as photoelectric that is work function. Now I am going to discuss a very important concept, that is experimental arrangement to study the photoelectric effect as well as that is the laws of photoelectric effect or experimental results of photoelectric effect. For that let us consider, that is the experimental arrangement to study the photoelectric effect experimental arrangement to study the photoelectric effect. For that we have to consider a diagram, that is it consists of an evacuated glass envelope with a quartz window. This is the quartz window. It consists of a glass envelope with a quartz window, and this is photocathode, let it be C, and anode, that is A, and this cathode is connected to a battery, and this is a micrometer or galvanometer, and these are all photoelectrons. These are all photoelectrons. Let us discuss about its construction. This is the quartz window and this is the glass envelope. This is anode, this is cathode, and this is the high tension DC battery, and this is the micrometer. So it consists of an evacuated glass envelope with a quartz window. This is the radiation of suitable frequency, and this is the one end is fitted with photocathode C and the other end is fitted with an anode A, and a battery in series with a micrometer or galvanometer is connected between this cathode and anode as shown in this diagram. That is, it consists of an evacuated glass envelope with a quartz window. One end is fitted with photocathode and the other end is fitted with an anode A. A battery in series with a micrometer or galvanometer is connected between this cathode and anode. When radiation of suitable frequency falls on this photocathode, obviously we know that emits certain photoelectrons. These are all the photoelectrons, and this anode collects these photoelectrons. Whatever the photoelectrons emitted by the collector are collected by this anode, and whatever the photoelectrons collected by this anode returns to this cathode through this external circuit that constitute photoelectric current, that we can observe, or that we can observe by the help of micrometer or galvanometer connected between the cathode and the anode. It means it shows certain deflection that indicates the presence of photoelectric current in the circuit. This is about the construction and experimental arrangement and how it works. Next, Here we are going to change the intensity of the incident radiation, or this photoelectric effect is studied for different intensities of incident radiation. By changing the intensity of the incident radiation, by changing the intensity of the incident radiation, by changing the frequency of the incident radiation, by changing the frequency of the incident radiation, and by changing the polarities of the electrodes, polarities of the electrodes. Here we are going to study the photoelectric effect by changing the intensity of the incident radiation, by changing the frequency of the incident radiation, by changing the polarities of the electrodes. And whatever the results we get by changing intensity or by changing frequency or by changing the polarities of the electrodes, whatever the results we get, that results we called as laws of photoelectric effect, are also known as experimental results of photoelectric effect. This is very important concept. So many times asked for 5 marks or sometimes 3 marks. For that reason it is very important concept, even in CET or JEE NEET also. So let us discuss laws of photoelectric effect or experimental results of photoelectric effect. Okay, let us consider one by one. That is, what are the laws of photoelectric effect. That is, first one, laws of photoelectric effect. Laws of photoelectric effect are also known as experimental results of photoelectric effect. If they ask laws of photoelectric effect or experimental results of photoelectric effect, both are same. So let us discuss the laws of photoelectric effect, and it is very important concept for both theory as well as competitive examinations. Let us discuss. First one, photoelectric effect is an instantaneous phenomenon. 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 Then what do you mean by this instantaneous phenomenon? It means there is no time delay between the incident radiation and the electrons ejected from the metal surface. Within the fraction of second, we can get the electron from the metal surface after the light falls on that metal surface or incident on that metal surface. It means ಇವತ್ತು ರೇಡಿಯೇಷನ್ ಇನ್ಸಿಡೆಂಟ್ ಆದರೆ ನಾಳೆನೋ ಅಥವಾ ನಾಡಿದ್ದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಲಿಬರೇಟ್ ಆಗೋಂಥದ್ದಲ್ಲ. ವಿತಿನ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ಸೆಕೆಂಡ್ the electrons are nearly 10 power minus 9 second in terms of nanosecond or less than that. Also we can get the electron from the metal surface. That is why it is known as an instantaneous phenomenon. It means there is no time delay between the incident radiation and the electrons ejected from the metal surface. So for that reason it is considered as an instantaneous phenomenon. Second one, number of photoelectrons liberated from the metal surface depends on intensity and independent of frequency of incident radiation. That is, number of photoelectrons liberated from the metal surface depends on intensity and independent of frequency of incident radiation. It means the number of photoelectrons liberated from this metal surface, that depends only on intensity of the incident radiation, and it does not depend on frequency of the incident radiation. Suppose if you plot a graph by considering intensity versus photoelectric current, that is intensity along x-axis and photoelectric current IP along y-axis. If you increase the intensity, the number of photoelectrons increases, and if number of photoelectrons increases, thereby photoelectric current also increases. Photoelectric current also increases. So the graph should be a straight line passing through origin. It means it varies linearly. If you increase the intensity, the photoelectric current also increases, because if you increase the intensity, number of photoelectrons increases. Number of photoelectrons increases, thereby the photoelectric current also increases. If you plot a graph by considering intensity versus photoelectric current, it should be a straight line passing through origin. It means it is linearly dependent. If you increase the intensity, photoelectric current also increases. This is the second law. And the next, third one, that is the energy of the photoelectrons. The energy of the photoelectrons, the energy of the photoelectrons depends on frequency of the incident radiation. Frequency of the incident radiation, and it is independent on intensity of the incident radiation. Intensity of incident radiation. What do you mean by this? That is, the energy of the photoelectrons depends on frequency of the incident radiation. Frequency of the incident radiation, and it is independent on intensity of the incident radiation, or it does not depend on intensity of the incident radiation. Then we know that if we increase the frequency of the incident radiation, the speed of the photoelectrons increases, but the number of photoelectrons remains same. That depends only on intensity. If we increase the frequency of the incident radiation, the speed or velocity of the photoelectrons increases. If the velocity of the photoelectrons increases, we know that obviously the kinetic energy of the photoelectrons increases, because kinetic energy is equal to half mv square. Here v is more, then kinetic energy is also more, because mass of the electron remains same, half constant, and velocity. If velocity increases, the kinetic energy also increases. It means if we increase the frequency of the incident radiation, the speed or velocity of the photoelectrons increases. And we know that if velocity of the photoelectrons increases, obviously the kinetic energy of the emitted electrons also increases. But it is independent on intensity of the incident radiation. This is the third law. Next we have to discuss fourth one. The photoelectrons are liberated from the metal surface surface, from the metal surface, only when the incident radiation, only when the incident radiation should possess certain minimum frequency, certain minimum frequency, and that frequency we call as, that is threshold frequency. Obviously we know this concept, that is the photoelectrons are liberated from the metal surface only when the incident radiation should possess certain minimum frequency. That frequency we call as threshold frequency. This is fourth one. And next, if you plot a graph by considering frequency versus maximum kinetic energy. If you plot a graph by considering frequency versus maximum kinetic energy, that should be like this. That is, along x-axis frequency, you have to consider frequency, along y-axis maximum kinetic energy, and the nature of the graph should be like this. And this is threshold frequency. That is, if I plot a graph by considering frequency versus maximum kinetic energy, it is linearly dependent. That means if you increase the frequency, the maximum kinetic energy of the photoelectrons also increases, but it should be after threshold frequency only, because we know that we get the electron from the metal surface only the incident radiation should possess certain minimum frequency. That frequency we call as threshold frequency. For that reason, the straight line we consider not from the origin, from this place, and that is that corresponds to nu naught, that frequency, that is nu naught, after nu naught. That is, if you plot a graph by considering frequency versus maximum kinetic energy, the nature of the graph should be like this. That is, it is linearly dependent. If you increase the frequency, the maximum kinetic energy of the photoelectrons also increases. And here one more concept is there, that is if you plot again, if we consider slope to this graph, the slope of this graph indicates a Planck's constant. That is Planck's constant indicate madukante. That is, if you consider the slope of this graph, that is frequency versus maximum kinetic energy graph, gives us the slope of this graph gives us Planck's constant value. And this x-intercept that indicates threshold frequency, and this y-intercept indicates photoelectric work function. This indicates threshold frequency and this indicates photoelectric. X-intercept indicates threshold frequency and this y-intercept indicates the photoelectric work function. And the last point, that is sixth one, that is, if you increase the potential, already voltage now increase ಮಾಡ್ತಾ ಹೋದ್ರೆ 1 volt 2 volt 3 volt ಈ ತರ. If you increase the potential, the number of photoelectrons increases, thereby photoelectric current also increases. And after some time, further if you increase the potential, positive potential, the photoelectric current saturates. It means it becomes constant ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ. Suppose if you reverse this potential, positive negative interchange ಮಾಡಿದಾಗ, if you reverse this potential, the photoelectric current decreases. If you interchange this polarities, that is positive negative interchange ಮಾಡಿದಾಗ photoelectric current decreases. ಯಾಕೆ ಅಂತಂದ್ರೆ, because ಇದು ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, ಇದು ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ನೆಗೆಟಿವ್ ಆದಾಗ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನು ಎಮಿಟ್ ಆಗ್ತಿರುತ್ತೆ ಈ ಕಡೆಗೆ, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಆದಾಗ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ. ಡ್ಯೂ ಟು ದಟ್ photoelectric current decreases. Photoelectric current decrease ಆಗ್ತದೆ ಅಂತಂದ್ರೆ, ಅದು ಯಾವುದೋ ಒಂದು ಟೈಮಲ್ಲಿ ಝೀರೋ ಆಗಬೇಕು, ಡಿಕ್ರೀಸ್ ಆಗಿದೆ ಅಂದರೆ the if we decrease the or if we reverse the polarities of the electrodes of this if we reverse this polarities of these electrodes, then the photoelectric current decreases and it becomes zero at a particular negative potential. That potential we called as stopping potential. That potential we called as stopping potential. That is, if we reverse the polarities of these electrodes or if we increase the negative potential, the photoelectric current decreases and it becomes zero at a particular negative potential. That potential we called as stopping potential. If they ask for 5 marks, better to write all these things. If they ask for 3 marks, first 3 or 4 laws is enough. Okay, this is all about that experimental arrangement to study the photoelectric effect and also laws of photoelectric effect. It is very important concept, laws of photoelectric effect or experimental results of photoelectric effect. That is, let us discuss one by one once again. That is, photoelectric effect is an instantaneous phenomenon. That is, there is no time delay between the incident radiation and the electrons liberated from the metal surface. Within the fraction of second, we can get the electron from the metal surface. Second one, number of photoelectrons liberated from the metal surface depends only on intensity and it is independent of frequency of the incident radiation, but frequency should be greater than threshold frequency or equal to threshold frequency ಆಗಿರಲೇಬೇಕು. Next one, if we increase the number of photoelectrons liberated depends on intensity and it is independent of frequency of the incident radiation. And we know that if you plot a graph by considering intensity versus photoelectric current, it is a straight line passing through origin. It means it is linearly dependent. If you increase the intensity, the photoelectric current also increases. And the third one, the energy of the photoelectrons ejected from the metal surface depends on frequency of the incident radiation and it is independent on the intensity of the incident radiation. Obviously, that is, if you increase the frequency, the velocity of the photoelectrons increases. If you increase the frequency, the velocity of the photoelectrons increases. Thereby, the photoelectrons gains maximum kinetic energy. And next one, if you plot a graph by considering frequency versus maximum kinetic energy, the nature of the graph should be like this only. And this x-intercept, that means here, if you increase the frequency, the maximum kinetic energy of the photoelectrons also increases. This x-intercept indicates threshold frequency and this y-intercept indicates photoelectric work function. And the slope of this graph gives us a Planck's constant. Next, if we increase the positive potential, the photoelectric current increases and it becomes saturates. After further, if we increase the positive potential, the photoelectric current saturates. Suppose if we reverse the polarities of these electrodes, it means that is by applying negative potential, the photoelectric current decreases and finally it becomes zero at a particular negative potential. That potential we called as stopping potential because it stops the photoelectrons to reach the anode. That is why it is known as stopping potential. The minimum negative potential required by an anode to reduce the photoelectric current to zero we called as stopping potential. What is stopping potential? The minimum negative potential required by an anode to reduce the photoelectric current to zero we called as stopping potential. These are all the laws of photoelectric effect and it is very important concept. So ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತೀನಿ. Okay friends, if you like this video, please share and subscribe. Okay, thank you.